Hello everybody, it is I, Baby Crone, and how are you guys today? Well, here I am, ready to talk about science. So today, the old crone was wondering and wanting me to do a little bit more research on Cern and what it is that Cern is really up to up in the labs down underneath the earth. Well, I am happy to tell you guys that we are going to be having a two-parter. That this episode is going to be about the God particle, or also known as the Higgs Boson, and the next episode is going to be about dark matter. So stay tuned for that. So let's talk a little bit more about Cern. So who is Cern? Well, it's an organization of European countries, and a few countries that I want to highlight is Israel, the United Kingdom, Spain, Greece, and Germany. Now there's 23 countries involved, and they are particularly interested in nuclear research. Yes,
Is it the United States?
No, the United States is not a part of it. However, we may contribute money to it, but we do not have any of our U.S. citizens working in the research teams there.
Oh, okay.
Yes. So
it's in Switzerland, right?
Yes, it is in Switzerland. So what CERN studies is nuclear research, and nuclear research is studying to create types of applications and devices that can help with medicine, safety, working on the environment, and also contribute to power. However, CERN in 2012, the year we all thought the world was going to end, they discovered the God particle. How fitting for the year 2012, right? And this God particle was proposed by Peter Higgs in 1964, who thought there had to be a particle out there that gave mass to all these other particles, because the question is, where is mass coming from if in space there's no mass? So that was the question. However, they did not know how to answer it. And these types of questions, there's a level. There's physics, and then there's quantum physics, which is where all the hypotheses and all the realities and different possibilities can come in handy. Like, is it this? Is it that? Could it really be? Like, you're not really sure. It's all hypothesis and not really entirely sure, and through discovery. So the Higgs boson proves that there's a Higgs energy field, and this energy field exists. So this could be considered the God field. And what this field is, it's an invisible field that's around the universe. And what it does is it contains this one particle, the Higgs boson, that chooses when to make a particle exist in reality. That's what it means by giving mass to a particle. So a way I like to think of it, I'm not sure if any of you guys played this game, but Duck, Duck, Goose as a kid. So the environment you're playing in is the Higgs field, and the person that's the chooser running around people in a circle. The circle is particles waiting to become reality and exist. Yes. Oh, and when you're running around in a circle, you tap one person, and that person you choose now suddenly has to get up and chase you around the circle. But that person you tapped is now part of reality, and now this particle has mass and can move around. Yes, old Crone.
Is it like a random? Like
yes, it's random.
Oh, okay.
Yes, it is very random.
Interesting.
Yes, now what makes this particle so special is that it does not have a spin. And a spin means that it rotates around itself. It's just stationary, like me just sitting here. It doesn't have a spin. I'm not spinning around. And also, what this spin does is allows it to interact with something. So if you're not spinning, you're not able to interact with something because you're just stationary. it has no charge either, and a charge is how you attract something to you or repel something to you. So if you're having no charge, something that has a charge is just going to bounce off of you because you just don't want to interact with it because you don't have the ability to. So what this Higgs boson does is it explodes into not like a million pieces, but it explodes into particles that now have mass to it through this field that it interacts with. Now, there are a few ways that this particle can exist. So the first way, it starts with being an extremely hot environment. So when the Big Bang first happened, boom, there was so much hot energy that there was no particles in existence. Everything was just hot energy just there. Ready energy that was ready for potential use. And what it did was there was symmetry. And what symmetry means in physics is that the particles remain unchanged after colliding. So they're just bouncing off of each other. They're not changing. But once it cooled down, this cooling down of the universe, this was a few split seconds after the Big Bang, this was below the energy field. So this Higgs field was a very high energy. So once you're below that energy, now you're able to gain a mass. So what this did was it broke symmetry, and by breaking symmetry, now you didn't have a mass, so it's like a probability. Do you have mass? Do you not? Okay, now you have mass. Okay, now you exist. That's what it was like. So now this particle has mass after the cooling down, and this mass particle was able to make galaxies, stars, and planets. And another way this Higgs boson works is when two particles collide with mass, they're able to break symmetry if they hit each other with the right speed and have the right charge and hit each other at just the right angle. They're able to change their molecular structure, and somehow a Higgs boson is plopped off like a byproduct. And now this particle can only be detected when it breaks down and new particles that seem to pop out of nowhere come into existence. And that's how you know that the Higgs boson exists, because particles that weren't there are now there and you're able to weigh them. So that's a little bit about what's going on in Cern and the research that they're doing. So as I was saying, this particle already exists in reality. It just needs mass in order to interact and create and form. So it's just ready potential. And to exist, you have to have a shape. And in order to have a shape, you have to have mass. Just like water. Water doesn't have a shape, but it has a mass. But when you put it in a container, it does have a shape. But that's kind of what we're talking about, like this fluidy liquid gas that you can't see, that's everywhere, and it's just waiting to be able to form and mold into itself and create something. And the Higgs boson gives that ability to those particles.
It sounds like a sci-fi movie.
It kind of does.
Like it sounds like, this is how I'm envisioning this. Okay. Like a mirror. Like, you know, it's like liquid. Mm-hmm. Like it's a mirror. And the mirror reflects everything. But because it's reflecting, you can't see it. Okay. Because it's just reflecting you. Right. You understand what I'm saying? Mm-hmm. It's there, but because it's so in your face, it's everywhere, and all it's like a fluid is reflecting. And maybe because I had that vision once, and I so understand it. I guess. Go ahead, I'm sorry about that. So, that's okay. But you remember that, right? Yes, I do. Mm-hmm. So okay, so talking about being existence is kind of like, if you guys understand what a noble gas is, going to chemistry, or an inert gas as they're called. They're gases that have full balanced charges, so therefore, like helium, for example, is a noble gas. Therefore, it's not reactive because it doesn't want to react with anything, because it's completely full in and of itself. So it just kind of exists there to help whatever it needs to do in the system. So like, for example,
we use helium to blow up balloons. Well, that's just what it's there for. It's not going to do anything else. So what uses can we get out of helium? That's what the Higgs boson is kind of like. Just going around looking at the particles that are floating in existence. And it's just like, I think I want to choose this particle to exist in reality to go do something. And then be like, no, not that particle, but okay, I'll choose this particle, and this particle can go do whatever it wants in reality. That's what the Higgs boson is like. And it's so random, and it's so unpredictable that it takes a lot of time to study these things. And it was only until 2012 when we discovered this. And really, this symmetry that I was talking about in physics, when I'll have some pictures here to show you guys a bit about symmetry. But when there's symmetry, as I said, everything remains changed when there's a collision. Well, there's a type of theory called supersymmetry, and this has to deal with the universe. And supersymmetry is when every particle in the universe is identical. This is what I mean, that everything was just there in the universe. Everything was the same. Nothing was different. You couldn't tell which particle was which. They was just already potential, waiting to be used. And this Higgs boson was after the Big Bang. So once this spark happened, this Higgs boson somehow, through this high energy, lost its speed, lost its momentum, and is just randomly floating. And I guess instead of saying picking, it like might float up and bump up against a particle. And it's like, okay, that's what we'll do. And that's all the God particle is. So I'm glad I was able to talk to you, the Munchkins, about the God particle. And next week we'll talk about dark matter and plasma, which is in the blood.